Basically, this is a fraction where we have two variables, t variable and time variable. Whereas the left-hand side, acceleration, constant acceleration. So now then we're going to separate the variable, separate the variable. First of all, the differential, how we solve it. First step, separate the variable. Second, after we separate the variables, we integrate separately. We take only two steps. So always to solve first order differential equation, first of all, we need to separate the variables completely. So left-hand side should have only one variable, whereas the right-hand side, only one variable. Two variables are completely separated. And then we integrate separately. Okay, and now then from this equation, we separate the variable. dv equals ac dt, left-hand side, only v variable here. Right-hand side, we have only t variable because a sub c is constant. So we did it. We did separate variables, then integrate separately. Next step, separate integral. So left-hand side, integrate with respect to velocity v. Right-hand side, integrate with respect to time variable t. Now lower limit, upper limit. When time is zero, then initial velocity v sub zero. This gotta be initial velocity. When time is any time t, let me delete some of those. Okay. This is any time t. At any time t, then this velocity, any velocity, no numerical value, just symbol, any velocity. Okay, then we integrate. We integrate the left-hand side. Left-hand side is simply dv. dv is the same as 1 times dv. So integrand is function to be integrated. Integrand of left-hand side is 1, simply the 1. Whereas the right-hand side, AC is simply constant. So integrate the left-hand side first. One. Antiderivative 1 respect to v is v. So left-hand side is v. Lower limit, v sub 0. Upper limit, just v, any v. That equals what? Plug in upper limit first. And subtract lower limit value, v0. See, that's why we have this one. Right-hand side then, right-hand side, AC is constant, we take it out. We take AC out. So AC times integral of dt. Then integrand again is 1 from 0 to anytime t. Antiderivative 1 respect t is t. Lower limit 0, upper limit t. Plug in t, plug in 0. T minus 0. t minus 0 is t. That's why we have this. Rearrange the equation, solve for a velocity at any time t. So velocity at any time t equals v sub 0 plus act. So in physics 1, we write this one. Final velocity equals initial velocity plus acceleration times t. Remember? Kinematic equation, physics kinematic equation. Okay. So v sub 0 is initial velocity. V is velocity at any time t. We can evaluate velocity at any time t. At any time t means at any instant we can calculate the velocity using this function. So therefore v is instantaneous velocity. Okay, so using calculus we derived physics kinematic equation, right? So what if a is not constant? Then we have to solve it. Kinematic equations, which are first order differential equations. So as I told you before, how to solve first order differential equation? First of all, we got to separate the variables. Second, we integrate separately. Any question? Good? Everybody good with that? Can you move on? Okay, next. Position as a function of time. Instantaneous velocity is ds over dt, right? And we already solved for instantaneous velocity in previous slide, which is v0 plus act. Then right-hand side, v0 is initial velocity, which is constant. A sub c is constant. We have t variable. Whereas the left-hand side, we have s variable, t variable again, mixed. To separate s variable, t variable, we multiply both sides by dt. In other words, we solve ds. Then this is ds. Then take a look at the right-hand side. We have only t variable. Whereas the left-hand side, we have only s variable. So s variable and t variables are now completely separated, right? And integrate separately. Time starts 0. When time is 0, then this is initial position. And this is any time. Again, this is position at any time accordingly. Okay then, left-hand side, integrand is 1. Antiderivative 1 respect s is s. So left-hand side s. Lower limit s of 0. Upper limit s. Plug in upper limit first. Subtract lower limit s minus s of 0. That's what we have right here. Okay, right-hand side, v0 is just constant. So then integral of v0 dt, v0 constant, we take it out, dt, then 1 is recognized. 1 times dt same as dt, so 1 is integrand from 0 to anytime t. Now then v0, antiderivative 1 is t. Evaluate from lower limit to upper limit. Upper limit t minus lower limit 0. That's why we have a v0t. Now then, second integral, a sub c is constant, take it out. T dt. from 0 to anytime t. Now in this case, integrand is t. Now then we need to find antiderivative of t. What is it? Anybody? Give me feedback. Hmm? Miguel, you took already Cal 3 last semester with somebody else. So anybody can answer antiderivative of t.
The antiderivative of t.
Mhm.
That'd be t. No, I'm blanking right now. Sorry. I think
It's
it's the
okay.
beginning of the semester.
Yeah.
T squared
Okay.
over.
Anybody else? Mhm. George, you're saying? Okay. Anybody?
Antiderivative, that's the situation where we're applying one to the exponent or something, or is that me overthinking that as well, or thinking the same thing as Miguel?
Yeah. Yeah. So
Would it be t squared over 2?
yes, that's right. Yeah.
Okay.
Yep. Okay. So reminder, right? If f of x, y equals x to the n, antiderivative usually square bracket like this. Power rule, raise power by 1, divide by n plus 1. That is power rule of antiderivative. So now, here is power is what? 1. Raise power by 1. So x of 2 divide by 1 over power plus 1. 1 over 1 plus 1. That is 2. So 1 over 2. Okay, then evaluate, right? 0 to t. Oh, sorry. This got to be t. I want to fix it by yourself. It's not x, t. Plug in upper limit. 1 over 2 t square minus plug in 0. 0 squared is still 0. So here we have. So we solve for s then. S equals, that is the final position equals initial position plus initial velocity times time t plus 1 over 2 at squared. In physics, what we used, instead of s, we used x. X final, remember? X final. Okay, let me write down here. X initial plus initial velocity times time t plus 1 over 2 at squared. If acceleration is constant, position is quadratic. Velocity is linear. So this is relevance, right? Okay. Dynamics, kinematic equation, and physics, kinematic equation. Okay, remember in physics, kinematic equations were derived with algebra. Now then, we use calculus, right? By solving first order differential equation. Okay, similarly, any question? Similarly, third kinematic equation is this. VdV equals ACDS. Initial condition, when time is 0, initial velocity v is over 0, and initial position given by s of 0. Okay, the left-hand side, we have only one variable, v variable, whereas the right-hand side, we have only one variable, s variable. Already, v variable, s variables are completely separated. Then we simply integrate. Left-hand side, integral of v over dv from initial velocity to any velocity v. Right-hand side, AC is constant, take it out. Then again, apply power rule, antiderivative v, that is half v square. V02, V, plug in V. That's why we have this, right? And we subtract V0 square. Right hand side, the 1 is recognized. Okay. Then antiderivative 1 with respect to S is simple S. Evaluate S02, S, plug in S, upper limit, subtract the lower limit value, S minus S of 0, right there. So rearrange the equation and we ended up this. In physics, what we had, the final velocity square equals initial velocity square equals 2a delta x. That was the fourth kinematic equation in physics 1, remember? Okay, so we derived physics kinematic equations when accelerator is constant using dynamics kinematic equations. Okay, we're going to work on textbook example problems, procedure of analysis. Okay. I'm going to use textbook. Textbook, where is it? Okay, there. Procedure is this. You set up coordinate, establish position coordinate. Symbol for the position is S along x-axis or y-axis. And you set up the origin and what direction is positive. Usually, horizontal axis to the right is positive, to the left is negative. Vertical axis up, usually positive. But if something is falling down, then downward would be positive. Okay. Of course, gravitational case, all is positive always, but not in this case, direction of motion set to be positive. Okay. All right, since motion is along the straight line, then if we move to the right, then that is positive, move to the left, then it would be negative. Something like this. Now then kinematic equations, you see, I already summarized the kinematic equations, 3 equations. We apply kinematic equations. That is a first order differential equation. Then using kinematic equation, we solve for velocity or position or something else. Maybe time too. Okay. All right then. From problem itself, we can find the lower limit and upper limit. Often we call the boundary conditions or initial conditions. Okay, let's work on the first problem of this semester. The car on the left in the photo and the figure down below moves along straight line such that for a short time its velocity is given by, as a function of time t, v equals 3t squared plus 2t feet per second, English unit. T is given in second, that is time. Determine its position and acceleration when time is 3 seconds. 3s means s is not, in this case, position. S is second. This is second. So initial condition is given when time is 0 seconds and position is 0. So this car starts from the origin then, right? When time is 0. And 3 seconds later, where this car is at. So we need to solve for position, right? And this is instantaneous velocity function. Instantaneous velocity is ds over dt by definition. That equals 3t squared plus 2t. Again, this is 1D differential equation because we have a first order different order derivative. Now where we have S variable, T variable mixed. Now we separate the variable, right? How? We simply multiply both sides by dt. In other words, we solve for ds. Then next step, integrate separately. Excuse me. Okay, just like this. We need to set up low limit, upper limit, but problem already gave us when time is 0, S is 0, T is anytime T. Again, anytime T, at any time T, then S is at any S. Left hand side, 1 is recognized. Antiderivative 1 respect S is S. 0 to upper limit. There it goes. 3t square, antiderivative 3. Now power is 2, 1 over power plus 1, and raised power by 1, t to 3. Here is 2, and power is 1, raised power by 1, 1 plus 1 is 2, then 1 over 2. 1 over 2 plus 1 is 3, is the cancel. So then t to 3 plus t second. Low limit 0, upper limit t, plug in upper limit, subtract low limit, then we ended up t3 plus t2. I mean power. The left hand side s minus 0, so s equals is this. T cubed plus t squared. Then position, we solve the position as a function of time t, then we can evaluate when time is 3 seconds. We simply plug in 3 into t. Three cube, 3 times 3 times 3. What is it? 27, isn't it? 3 squared is 9. 27 plus 9, 36 is given feet. Okay, this is it. Okay, let me check. Textbook answer. This is correct one. Yep, this is it. Okay. Now it asks acceleration, then acceleration is the derivative of position. Oh, sorry. Derivative of velocity. So that is easy, isn't it? Acceleration. Velocity is 3t squared plus 2t. 3 times derivative of t squared, 2t. So 3 and 2t plus 2 times derivative of t respect to t, that is 1. 6t plus 2. So evaluate acceleration when time is 3. A over 3 then. 6 times 3, that is 18. 18 plus 2, 20 unit feet per second squared. Of course, 3 digits, 3 significant figures. Okay. Any question? Now today you learn how to solve first order differential equation. Probably someone who already took differential equations should know this thing, right? Mostly in a differential equation class you solve for second order differential equation. Any question? Oh, let's check textbook answer. Yeah, 20, yes. Okay, basically the same as textbook solution, so what you can study with your textbook. Okay, let's move on. Can you move on? All right, this example, a little bit challenging, this one. Small projectile is fired vertically downward. So we said downward is positive then, because direction of motion of a small projectile is downward into fluid, a medium, with an initial velocity of 60 meters per second. When this projectile hit this fluid medium, its velocity 60 meters per second. Because of viscosity, this projectile will slow down, eventually will stop. So due to drag resistance, that is viscosity of a fluid, just like engine oil, very viscous, very sticky. Projectile experiences deceleration. In physics, we do not use terminology of deceleration. Instead, we simply use acceleration, but traction is opposite to motion. That's why acceleration is negative. Negative 0.4 velocity cubed meter per second squared, where v is given in meter per second. V is the velocity, instantaneous velocity. So this is confusing, right? I mean, complicated. Acceleration function of instantaneous velocity, not as a function of time t. Then determine the projectile velocity and position 3 seconds later. Okay. Coordinate system, since motion is downward, we said downward is positive. All right. At the surface, we set up the origin. Now, acceleration. Acceleration is the derivative of velocity with respect to time t. Okay, start off definition of acceleration. That equals negative 0.4 v to the third power. Okay, the left-hand side, v and t, two variables, whereas the right-hand side, only v variable. Then we need to separate the variables, right? Okay, first of all, we solve for dv. b to the third power and dt. Even though we solve for dv, that doesn't separate v variable, t variable. Instead, right-hand side, we have a v variable, t variable mixed. Now then, we divide both sides by negative 0.4 v to the cube. And then cancel, cancel. Now the left-hand side, negative 1 over 0.4 1 of v to the cube is v to the negative 3 and dv. And right hand side is dt. Hey, this is it now then. So you look at the left hand side, we have only one variable, velocity variable, whereas the right hand side we have time variable. Then we are now ready. Integrate separately, right? Okay, initial condition was given. See, initial velocity, 60 meters per second. When time is 0, velocity initial equals 60. Okay, then we integrate separately. Initial 60, final any velocity v, that equals dt. Initial 0, anytime t again. All right. Right hand side is straightforward. It's because 1 is recognized. Integrand is 1, whereas with the left hand side we have v to the third negative 3 power. So then we apply power rule for the antiderivative. Now raise power by 1, divide by raise the power, right? This is it. Okay, then 62 any velocity v. Right hand side is straightforward. Antiderivative 1 with respect to t is t. Low limit 0, upper limit t. So this is simply t minus 0, simply t. Okay, this is it. Then a little bit cleanup. Okay, so negative 3 plus 1, that is negative 2. So do multiplication this one. So that is negative 1 over 0.4 times negative 1 over 2. Negative multiplication. That is what? Positive. 1 over 0.4 times 2, that is 0.8. So this is it. Left hand side then 1 over 0.8 positive. Upper limit v to the negative 3 plus 1, that is v to the negative 2. So v to the negative 2. Subtract initial value 60, negative 2. That equals t. Okay. So now then we solve for velocity v. Okay, so from now on we do algebra, right? Multiply both sides by 0.8. V to the 1 over 2, v to the negative 2, that is 1 over velocity square minus, again, 1 over 60 square. That equals 0.8 t. Now solve for 1 over velocity square. That equals 0.8 t plus 1 over 60 squared, right? Then we simply flip to solve for velocity square. And take a square root on both sides. We choose only positive. Square root is basically what? Power is negative half. Oh, half. Or if you want to, you can use a square root. This is it. So if you take a look at textbook, basically same as this, right? Yeah, same. Same. Okay. We simply flip this one, that is negative, negative 1/2. Okay. We got the velocity, the function as a function of time t, and the unit meter per second. Okay. Then we evaluate the velocity when time is 4 seconds. Plug in 4 into t, and using calculator, we can calculate the velocity when time is 4 seconds. We ended up 0.559 meter per second. I'm not going to do that, but you can do it, right? With the graphing calculator. Okay. Question. So I simply use power rule for the antiderivative. And then simple rearrangement with algebra to solve for the velocity as a function of time t. Okay, what is next then? Position. Once you solve for velocity, then velocity that is instantaneous velocity. So then this is it. We're going to start off from here. Velocity equals ds of dt. That equals square root of 1 over 0.8 t plus 1 over 6t squared. Now then, left-hand side, s variable, t variable mixed. Okay. Okay, we can start from here. All right. We separate s variable, t variable, multiply both sides by ds, dt. Then the left-hand side, ds, right-hand side, 1 over, of course, the square root of 1 over square root of 1 over 60 squared plus 0.8 t. Integrate with respect to dt. Low limit, obviously, for the time is 0, upper limit t, and position 0 to NES. Now, question is how we integrate this guy. That is the thing. Left-hand side easy because 1 is recognized. Antiderivative 1 with respect to s is simple s. Plug in upper limit, low limit, then s minus 0. So left-hand side is simply s. What about this? Question is this. How we integrate? Let me rewrite this one. There is a negative 1 over 2. 1 over 2 is a square root. So we send this one because negative power. That is the same as square root 1 over square root of
We started a street gang on this
0.8
block here, a street organization. I was like 9 years
plus
old. 9 years old when I first got
1
involved
over
with it.
60
Where they coming
squared.
from? Behind us.
This
How we
is Chicago.
integrate?
Known
This
for its
is my
museums,
question
food scene,
to you.
and right now,
Chicago police warning the public about a burglary spree.
2 victims shot and
How
killed
we
in this
integrate?
armed robbery.
4 stabbed.
I see Blake, George, Ian, Jackson, Jonathan, Max, Michael, Miguel, Skylar, Taylor, Tim. Anybody? Let me have your feedback.
You add 1 to the exponent.
In other words, you're using power rule, right? Power rule for antiderivative. That's what you said, basically. Jonathan, is that right?
Yeah.
So in other words, this is the power. 1 over 60 squared plus 0.8 t, and power is negative 1 over 2. Then raise power like this, 1 over 2 plus 1 and 1 over negative 1 over 2 plus 1 is 1 over 2, like that. In this case, we cannot do that because we have additional term. We have only this guy, then we can do that. If we have only 0.8t to the negative 1 over 2, then we separate them, 1 over 8, negative 1 over 2, t to the negative 1 over 2. This is simply constant. We apply power rule now, but we have additional term. This negative 1 over 2, this power applied to this additional term too. So because of this additional term, we cannot apply power rule. Text of author, solve it right away. See, right away, and evaluate right away. There is some steps, some procedure skipped. By myself, I can do that right away like this, just like author. So
Would
if
we
you
use V
have,
substitution for this one?
that's right, yeah. So how we sub then? You tell me. Yes, that is the answer. Yeah, substitution. Yes.
Just
And then
let
what is
zero.
yeah, go ahead, go ahead.
Okay, yeah, just let 0.8t plus 1 over 60 squared be u.
Yes, very good. Very good. Make it simple. I gave you hint because of x additional term, we won't be able to apply power rule. Then why don't you write whole thing? Okay. Sub, yes. Very good. Substitution method. Yeah. If t is given, say upper limit is simply say 3 seconds, 4 seconds, or whatever seconds, then we simply type integrand into your graphing calculator, and graphing calculator can do definite finite integral if this is given, upper limit given in number, but in this case time we don't know, right? Time is not given. Yes, sub. I'm gonna sub whole thing. 0.8 t plus 1 over 60 squared, say u variable. Okay. Once it's up, then we have to change lower limit and upper limit accordingly. Okay, look at the original integral, let's call it I. We have t variable. Now do we sub 0.8 t plus 1 over 60 squared for u. Then we need change dt to du. This is called the differential. Kind of remember differential? Okay. So all of these about what? You learn all of these, you learn in Cal 1 and Cal 2. So we're going to use Cal 1 and Cal 2. Differential, you learn differential in Cal 1. And substitution method of integration learned in Cal 2. Okay. Now then, to switch d to 2 du, we apply. We simply left hand side we have t variable. with constant, right hand side u variable. Then simply apply differential. Okay, your reference differential. Suppose we have function y is a function of x. Now then differential definition is this: dy equals right hand side is a function of x. So we take derivative. This is definition. Why is that? See? This is simply what dy equals df, isn't it? See? As I told you before, derivative is considered as fraction. So what? You cancel dy, dy. So it turns out to be this. Now then, this guy is what then? This is derivative of f with respect to x. Symbol for the derivative, we use dot or the prime, right? This is f prime and dx. Now then we have function is this. Then we take a derivative with respect to t of this and dx. Oh, sorry, dt. So derivative of 0.8 t with respect to t is what? 0.8. Derivative of 1 over 60 squared with respect to t is 0. So 0.8 dt. See? I did this part. And then followed by dt. Because we take a derivative with respect to t. That equals du. Now then, using this, we can replace dt equals what then? 1 over 0.8 du. Yes? So, this is it. Then, we got to change lower limit, upper limit accordingly. Time starts from 0 to t. What about the u then? U, plug in 0 into t. This is relationship between t and u. That is substitution method. Plug in 0 into t. Then u becomes 1 over 60 squared. Okay, plug in t right there. That is simply what then? U. Okay. Okay then. It'll become what then? If we use the substitution method, the lower limit with respect to u is 1 over 60 square root 2 upper limit u. This is 1 over square root of u. And dt is 1 over 0.8 du. Then notice 1 over 0.8 is constant. Take this out of the integral. And notice 1 over square root of u in power, that is same as u to the half. Then u to the half in the denominator, so u to the negative half. Now we can use what? The power rule. Yes? We can use a power rule. Okay, we use a power rule now then. Okay. 0.8. Apply power rule then. It'll be what? 1 over negative 1 over 2 plus 1 and raise power by 1, u to the negative 1 over 2 plus 1, and evaluate low limit 1 over 60 square root 2 u. I'm going to delete this guy. Okay, then plug in upper limit. I touch something, so what is scrub? Upper limit. Then 1 over 0.8. 1 over negative 1 over 2 plus 1. That is what? That is negative 1 over 2 plus 1. That is 1 over 2. 1 over 2 in the denominator. 1 over 1 over 2. That is 2. So then times 1 over 0.8 turns out to be 1 over 0.4. Then u to the negative 1 over 2 plus 1, that is 1 over 2, 1 over 2. Put upper limit, u to the 1 over 2, minus 1 over 60 square root of 1 over 60. That is simply 1 over 60. Okay, that equals what then? 1 over 0.4. Now at the end, we plug in back. U was what? 0.8 t plus 1 over 60 squared. So plug in back. And square root minus 1 over 60. I want to fix textbook. This got to be positive. It's not equal sign. Okay, so this is it. This is position. Then eval position when time is, I forgot, when time is 4 seconds or 3 seconds. Plug in 3 seconds or 4 seconds into t. And then you clean up and clarify this one. Then S turns out to 4.43 meter. So for the complicated function type of integrand, best bet would be sub. Sometimes sub works, sometimes a sub doesn't work in the case what you're going to do. If upper limit is given in value, then we simply type the function, integrand function type, into calculator. Calculator can calculate for us. Okay, in this case, upper limit is just symbol, so calculator would not be able to calculate that one. Okay, then we use substitution method. Okay, so this is good time to go back to Cal 1 and Cal 2, restudy, okay? Substitution method, the differential, definition of differential, things like that. Any question? Harder than physics 1, right? Because we solve first order differential equation. In the physics 1, we used just algebra, but now in dynamics, we use Cal 1 and Cal 2.
Professor, can you hear me?
Yeah, go ahead.
Okay, hold on. I just wanted to know what, so for the ending of that equation, it's 1 divided by 0.4, and then it's the square root of 1 over
Over
1 over 60
60.8
squared plus 0.8
t.
t.
That is t. Because we saw 0.8 t plus 1 over 6 squared by u.
Okay, and then is that minus 1 over 60? Is that external of
Yes,
the square root thing, or is that is that
because
supposed to be internal of that as well?
we take square root of 1 over 60 squared.
Okay.
That comes from basically what? Square root of 1 over 60 squared. So that turns out to be this.
Oh, okay, thank you.
Yeah. Anything else? Any other questions? So, you need to study. Okay, so, text author skip the part. Text author skip the part from, let me see, from, yeah, text author skipped from here to there right away. Text author got this one right away. Oh, I can do that by myself. The right away I can get this one. But the detailed procedure is this. Using substitution, we could get this one. This is the reason why you need me. Huh? Of course, you can study by yourself by reading textbook, but in many cases, even the physics, textbook authors skip some detailed mathematical, procedures. Okay, skip 12.3. When acceleration is constant, we can simply apply. Oh my gosh, sorry. Our time's over, isn't it? Our time's already. When we supposed to stop?
I think it's 3:20.
3:20. Oh, 10 minutes over. Sorry about that. I hope you don't mind, right? Because you learn a little more. Okay, so we're gonna skip the 12.3 and the 12.4. We're gonna work on 12.4 and 12.5 the Thursday. Okay, so this is it for today. First day we already learned hard stuff. So I want you to study by reading your textbook. I gave you some idea of substitution method and the idea of power rule of antiderivative and definition of differential. Now then study time. Okay, this is it. Thank you for your attention. I'll see you Thursday.
Dr. Yun,
Mm-hmm.
I came in late. My name's Jonathan. I just
Yeah,
want to make sure you had
yeah,
me.
I got you down. Don't worry.
Okay. Okay. Thank you.
Okay, yeah, I saw you came in. Yes. Alrighty, I'll see you Thursday.